Hello viewers, welcome to another awesome video with Mathemasoft. In this video, we shall continue with our studies on SURDS. So in this video, I'll be discussing with you simplification of SURDS. And I want us to quickly review what we discussed in the last video. In the last video, I already shared with you some basic principles that can guide you when it comes to simplification of SURDS. I talked about multiplication, where we establish that if you have root m multiplied by root n, then this means the same thing as what? All root m times n. And we can actually use a number to prove that this principle is not just something we imported into mathematics. It is something that is actually following basic principle in mathematics. So if we take an example, let's put a number, root 16 multiplied by root 4. Okay, so if we solve this separately, square root of 16 will give me 4, and square root of 4 will give me 2, and 4 times 2 will give us what? 8. What if we do the one with all root also, where we have all root 16 times 4? Then we have all, root 16 times 4. If you multiply this directly, it's going to give me 64. So what is the square root of 64? Square root of 64 will give me 8. This actually proves that either we have the roots separated on each of the numbers like this, or we have the roots rolling on all of them, both of them like an umbrella like this. The answer will still be the same. Hence, we establish that what? Root m multiplied by root n equals all root m times n. So this is what we established when it comes to multiplication. So the same thing we can also prove for division. Okay, so let's briefly look at that also. It's very important. Division, okay, in division we say if we have root m over root n, this will mean the same as all root m over n. And the same number that I use as an example in multiplication can also be used for this. We can say example root 16 over root 4. So if I do this separately, square root of 16 of course will give me 4, square root of 4 will give me 2, and this answer will be what? 2. What if I have all roots now? Then I can say all root 16 over 4. Will it give me the same answer? Let's look at that. So I can have root 16 divided by 4 will definitely give me 4. So what is the square root of 4? Square root of 4 in the positive sense will give me 2. So you can see that what? Either I have them being divided separately or being divided together with just a root as an umbrella on both of them, it will give me the same answer. So this is valid for multiplication and division. But we need to take note of that of the exceptional case we have when it comes to addition and subtraction. And that's what I want us to briefly look at now. So what if it's addition, okay, that I have, okay, when we are adding together, then we say that root m plus root n is never equals to all root m plus n. This is very important, and you should avoid making mistakes like this when simplifying SURDS. Let's use numbers, the same numbers that we use for multiplication and division, to test out this if it's actually what correct. So if I have, okay, root 16 plus root what? 4. Then root 16 will give me 4. Root 4 will give me 2. The answer here will give me 6. What if I have all roots? If I have all roots, I'm going to have 16 plus what? 4. And that will give me, 16 plus 4 will give me 20. That's root 20. Square root of 20 can never give me 6. In fact, if we apply simplification of SURDS, which we are about to do in this video, you will see that root 20 will simply just give me root 4 times root 5, and then that will give me 2 root 5. Okay, 2 root 5 is never the same as what? As 6. Therefore, we say that root m plus root n is not equals to or root m plus n. This is very important for you to take note of when simplifying SURDS. The same thing goes for subtraction. Okay, it's also an exception to the rule because it works like that of addition. So let's say subtraction, right? Subtraction, so states that minus, okay, root n is never equals to or root m minus n. So very important. Let's also use number to test out this. Okay, root 16 minus root 4. Okay, if we do this separately, 4 minus 2, that will give me 2. Let's treat it together now. Root 16 minus 4, this will give me root, okay, 12. Root 12 is never equals to 2 because I can separate this to 4. Root 4 times root 3, okay, and this will give me 2 root 3. 2 root 3 is never the same with what? 2. Therefore, we say that root m minus root n is not equals to or root m minus n. This is our previous knowledge in SURDS, judging by the last video that I uploaded on SURDS. So now we want to look at simplification of SURDS, and we are going to start with what? Simplification of a single SURD. Having established all these basic principles that guide the simplification of SURDS, so we can begin to look at simplification of SURDS. And we are going to begin with simplification of a single SURD. So let's take some examples, just like 3. Simplify. Okay, let's have okay, the first one, root 128. Okay, let's also have the other one, another one, root 27. Okay, let's try out these two first. Okay, so before you can simplify SURDS or single SURDS like this, it is very important that you remember your knowledge of prime numbers. And what are prime numbers? Prime numbers are numbers that have only 2 factors. Prime numbers are numbers that have only 2 factors. Or you can say prime numbers are numbers divisible by 1 and itself only. Okay, so for example, the first prime numbers that you will come across when it comes to natural number, you say 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is a prime number, 17 is a prime number. Why are these called prime number? Because factors of 2 are only 1 and 2. Factors of 3 are only 1 and 3. Factors of 5 are only 1 and 5. Factors of 7 are only 1 and 7. So, a prime number is a number that has only 2 factors, 1 and itself only. Or, you can say a prime number is a number divisible by 1 and itself only. So, hold on to this first. Now, another knowledge that we should have is the knowledge of perfect squares. Okay, let me share that. Perfect squares. Okay, what are perfect squares? All right, perfect squares are numbers that you can directly find their square roots. Okay, you can directly find their square root, or they have whole number square roots. Okay, they have whole number square roots. Let's take it like that. They have whole number square root. For example, square root of 1, okay, is actually 1. Then we say 1 is a perfect square. Square root of 4 is what? 2. You can see by the definition, I said that perfect squares can be said to be numbers that have whole number square roots. Whole number square root. The square root of 4 is what? 2. This is whole number. The square root of 1 is 1. This is whole number. Okay. And then we say 1 is a perfect square. Is a perfect square. Perfect square. I'm using PS to actually denote that. 1 is a perfect square. Okay. Let me write that. 1 is a perfect square. Here, what it means is that what? 4, okay, is a perfect square. 4 is a perfect square because it has whole number square roots. Okay, square root of 9 will give me 3. Therefore, 9 is a perfect square. Okay, square root of 16 will give me 4. So because these numbers, okay, their square root is whole number, then those numbers are referred to as what? Perfect square. 16 is a perfect square. Okay, so we know that the root of perfect squares, okay, would never result to a surd. The square root of a perfect square will never result to what? A surd. It will result to a rational number rather than irrational number. So square root of perfect square will give you rational number. That is why it's very good that you should have this knowledge. Now, why have I discussed about prime, okay, numbers and okay, perfect square? When you want to simplify sorts, you should think of splitting them down to, a perfect square. At least one of the numbers you want to split it down, because what do we mean by simplification? When you are told to simplify something, it means that they are asking you to break it down to smaller pieces. Simplifying something means that what? They are giving you something complex and they want you to what? Break it down to what? Smaller pieces. It's just like giving you this pen and I'm asking you that what? You should break this pen down into smaller pieces. So you should cut it down into what? Smaller pieces. Alright? It's just like you taking your plantain and cutting it, slicing it down into slices. Okay? You put it down in slices. That is what, instead of having it what? As just one like this, big one like this, I want you to what? To cut it down. So it means that you should simplify it. So they are giving us such a big, roots of number like root 128. And they want us to what? Simplify it. So we have to break it down. Now, the skills is that if you are going to break it down into at least a number out of the number you break it down to should be a perfect square. And in most cases, when you want to break down to what? A perfect square, at least also think about using your prime numbers. Let us put that up in our example now and see what I've been trying to explain to you. So let's practicalize it now. Okay. Let's practicalize this. Okay. All right. Solution. Root 128. Now, try to start with your prime numbers first. What is the smallest prime number? That is what? 2. When you have tried 2, try 3. When you have tried 3, it does not work. The next prime number is 5. When you have tried 5, it does not work. The next prime number is 7, and so on and so forth like that. Try to work in that stead. So I will first try to divide 128 by a prime number and check if the second number will be a perfect square. I hope you understand that. So if you divide 128, okay, by 2, let's try it, which is the first prime number. Let's divide it by 2. That will give me 64. Then I will think, this 64 that is giving me, is it a perfect square or not? And when you carefully look at it, 64 is a perfect square because square root of 64 will give us 8. Therefore, it means that I can separate root 128 to something like 2 times 64. I hope you are getting this now. So I can break 128 down to 2 times 64. Knowledge of prime number and perfect square. The 2 here is a prime number. The 64 here is a perfect square. And that makes sense. So you should start with dividing the number first with your prime number. If I've divided by 2 and it does not give me a perfect square, then try to divide by 3. If that does not work, divide by what? 5. If that does not work, divide by, in fact, sometimes you can divide by 2 and still divide by 2 again. So sometimes that might actually lead to what? A perfect square. However, the more you do this, the more you become perfect at it. So, having seen this, so let's now resort to, I think we can have our third example as root 125. Let's note that. We can also take that. Okay. So I will now separate this into root 2, root 64, because according to the principle of multiplication of surd, I can write it like this. So I can now say this will be root 2 times, what is the square root of 64? That is 8. So multiplying these together will give me 8 root 2. And this will be my what? Final answer. Okay. So let's take the second one. That is what? Root 27. Root 27, okay, if you bring 27, you have to know that 27 is an odd number. Okay. Recognizing if 27 is an odd number or even number can make your work faster, because if it's an odd number, I know that I don't have to waste my time dividing it by 2, because it will not be divisible by 2. Odd numbers are numbers not divisible by 2. So the first thing, prime number I will try out to save my time here will be 3. Okay, so if I divide by 3, that will give me what? 9. And looking at 9, 9 is a perfect square because it has a whole number square root. If I find the square root of 9, it will give me a whole number, which is what? 3. So I can see that I have a perfect match here. That means that root 27 can be splitted down to square or root 3 times 9. Okay, or root 3 times 9. Then separate it using multiplication principle. That is root 3 times root 9. So that will give me root 3, okay, times 3. And this will give me what? 3 root 3. Okay. This is the simplification of root 27. Number 3, let's look at root 125. Okay. Looking at 125, I know that is an odd number. How do I know? Because it ends with an odd number. How do I know that this is an odd number? Because it ends with an odd number. How do I know that this is an even number? Because it ends with an even number. Okay, so just check the number that a number ends with. It will tell you the identity of that number. If it ends with an even number, it is an even number. If it ends with an odd number, it is an odd number. So 125 is an odd number. So I can try out 3 if you want to. I know 3 will not work, but as a beginner, first try it. If you have your calculator, that will save you the trouble. So this will be 4, okay, 1, and then I see that there will be what? Remainder 2. Oh, so there should not be any remainder. 3 cannot work. What's the next prime number? The next prime number is 5. So let me try out 5. 5 in 12 will give me 2, remainder 2. 5 in 25 will give me 5. 25 is a perfect square, so I have a good match for this. So I can separate this to 5 times 5 times 25. Okay, so I will use the principle of multiplication of surd to separate it to 5 times root 25. Now that I have root 5 times root 25, then I can write root 5 times 5, because square root of 25 will give me what? 5, and that will give me 5 root 5. So exactly this is how we go about simplification of single surd. In the next video, I'll be discussing with you how you can reverse this process. For example, they can give you something of the nature 5 root 5, and they are asking us to write it like a single surd like this. They can give us something of the nature 3 root 3, and we may have to write it as a single surd like this. We may have something of 8 root 2, and we may have to write it as a single surd like this, and that will be our next video. Please share this video, comment, like, subscribe, hit the notification bell if you have not done so that you can always get notified anytime I drop a new video.